Hey, this is Tyler with another update on the HoloLens project. So right now we're going to make a 3D reconstruction. The first step is to define the isosurface threshold, interaction mode threshold, so that we can see we've got it already set to about skin. If I wanted to make a bone reconstruction, I would do something like this, but we'll set it to skin. Okay. Build marching cubes. Hide slice. Okay. So you can see that there are these kind of faint purple tiny little triangles that are floating into the volume. And what's going on here is this algorithm, which is called marching cubes, is solving for all of the tiny little triangles that we need to put into this volume to make the surface that we chose with our threshold. This algorithm has some fundamental limitations. First off, as you can see, it takes a long time to get all of these triangles. It comes out to several hundreds of thousands of triangles that we have to put in all the right places to get the full surface rendered. So it takes a long time to build. We don't get an instantaneous representation of the surface. We have to settle for this will take several minutes. And this is a very small data set. If you could imagine a very large data set like a chest, abdomen, and pelvis CTA or something like that, it would take very, very long time to solve for the isosurface. The other problem is that we end up with this very large mesh. So it takes up a lot of space in memory. This is not really a huge problem on most workstations that you might use that have many gigabytes of memory, but the HoloLens is a little limited. It only has 2 gigabytes of memory. So even if we were willing to wait long enough to build a giant mesh for a very large study, the device would probably run out of space. So it's not a total lost cause. Marching cubes still has important uses. For one, you get a representation of the surface as a mesh, which can be useful if you want to do things like, say, send the object to a 3D printer. It also has use if you want to do any kind of analysis, surface analysis. And it's easy to imagine how the HoloLens would be very useful to, say, compare a mesh from a medical study to the mesh of the environment around me that we already know that the HoloLens continually creates. The other way that 3D reconstructions are done in medical imaging, and the way that they're mostly done now, is with ray casting. That's the kind of isosurface reconstruction where you get almost instantly a representation of the surface that's useful. So that would be the next step to implement on the HoloLens. But for now, we've got an implementation of the marching cubes algorithm. So here we are a couple minutes later, and the mesh is finishing up. And it's done. Sagittal view, axial view, coronal view, coronal view. Thanks for watching.